My name is Nicholas de Montchaux. I'm an assistant professor of architecture and urban design here at Berkeley, and it's my pleasure to kick us off with the first of 3 afternoon panel discussions, which will include some presentations and then also a larger discussion amongst the group here, and then we hope with you as well, engaging the various issues in front of us. Now, it's very interesting. I was just commenting to Susan Buckley of the MIT Press, who's here, that it's been, because of some initially unrelated research I did, as it happens, on the history of the Apollo program, I had the occasion over the course of the past several years to read into what was probably the first go-round of an attempt at urban systems science in the late 1960s and early 1970s. There was actually even I kid you not, a summer school at UC Berkeley in the summer of 1971 training engineers from the aeronautical professions in what was called at the time urban system science. And maybe even in this very room. That said, this really gives rise to the question of 2 questions. First of all, is there anything different this time round? And secondly, given the what were at the time the kind of various manifold failures of the first attempt to build a kind of urban science around a systems perspective, what might we seek to do differently the second time round as well? And these issues lead into, I promise you, this panel, because I think that there are, in terms of what is different this time round, I think there are some very essential and very important differences. Chiefly, I think, or first and foremost, the way in which much of the work we've seen this morning and much of the work around which the conversations of the Urban Systems Collaborative go is fundamentally data-driven. And that is to say, looking at the city as an object that we are able to, through the new media of urban informatics, perceive in new and unexpected ways, and therefore have to, in the best tradition of science, form and test theories about the operations of cities. And secondly, I think that the most interesting potential comes from the way in which a new science of cities is itself revealing the kind of, in Jane Jacobs' words, the kind of problem a city is. And that is to say, we are much more comfortable with the particular character of complex, self-organized, multivalent, and fundamentally unreducible problems that urban problems turn out to be. As we seek to address the problems of the cities in new ways, and as our century itself is faced with new kinds of problems in cities, I think we have to think about a couple of different kinds of hierarchies, each of which we've tried to highlight in the panel this afternoon. The first, represented maybe most manifestly by my colleague Mike Migurski from Stamen Design in San Francisco, are the visual and conceptual hierarchies that the non-trivial question of how we interpret, perceive, and shape the information that is allowing us to address the problem of the city in new ways. The work of Stamen, I probably don't need to explain to this audience, is singular in this field, shaping urban visualizations and shaping the ways in which urban visualizations are themselves being formed as a kind of practice. And so I really look forward to Mike's contribution. I think the other hierarchy, the non-trivial hierarchy that was, it may include that big red word privacy we saw on the bottom of the first set of slides this morning. But the second set of hierarchies that I think are very much non-trivial as we address these questions are political hierarchies. And I'm talking about politics not just in terms of disorganized urban administration, but also the politics of data, the politics of knowledge, and the politics of privacy, and how how we can hope to make the issue of data generation and analysis in cities reflect the kind of multivalent bottom-up as well as top-down hierarchies that we are increasingly aware that cities themselves encompass. And then the last kind of hierarchy is addressed probably by the whole panel as a group. Or I should say, here, this is my casting, not yours, but speaking, I think, particularly to the idea of the politics of data in cities and to how we make data accessible and available and manipulable by the widest community possible. I have my colleagues Abhi and Nemani from Code for America, stepping in for Jennifer, who had stepping in very ably for Jennifer, I should add, who had to fly off this afternoon, and also my colleague Paul Wadell from the Department of City and Regional, Chair of the Department of City and Regional Planning here at Berkeley as well. And lastly, if I can try and articulate a final point on this theme, I think what is most interesting, if we think back to that really important last chapter of Jane Jacobs' Death and Life of Great American Cities, titled The Kind of Problem a City Is, in which she makes a case for the links between recent work at that time in the life sciences on problems of self-organization and organized complexity, the kind of network effects that the work of Jeff West and others has charted in urban statistics. We can really say that the most kind of enticing and exciting generator of the kind of conversations that we're participating in today is the increasing sympathy and even synergy between the technological networks we create and the deep network effects that are already manifest in urban landscapes. And I think the work of Alex Bayen and his colleagues is particularly interesting in this regard, trying to find those resonances, exploit them, and explore them to the better functioning of cities and communities as a whole. So that's my attempt to kind of synthesize the group as we've presented it to you today. We'll have brief presentations from those in the group that you didn't see a presentation from this morning. That's for Paul and Mike and Alex will present briefly, and then we'll open up the conversation to them. You've probably heard enough of my voice, but I'd really like to hear more of your voice and more of their voices in the hour that we have before 2:30. So why don't we just go in order down the row, and if you'd like to start, that would be great.
Okay, so my name is Alex Bayen. I'm an associate professor in the Electrical Engineering Computer Science Department and in the Civil Engineering Department. And first I want to express my thanks to the organizers and particularly to Nicolas for the invitation. I'm very happy and excited to be here. So in a very short amount of time, what I want to go through is the revolution we just went through in terms of the data that is collected today, that can be collected today, and touch on some of the issues of citizen engagement, and specifically about what is known and unknown, and done willingly, unwillingly, knowingly, unknowingly, when using that data and what can be done with it. I want to do this in the context of traffic very briefly. I think over the last 5 years, we've witnessed an extraordinary change in the way traffic monitoring is done. What you see here is probably something you're familiar with if you live close by. Changeable message signs that actually are operated by UC Berkeley, and the MTC traffic display of a couple years ago. And what's striking here is that this is what was available, I would say, 2008. In terms of traffic information, and the traffic information on the website is fairly limited. It's just the freeways. And that's because we have thought about urban infrastructure and in general mobility in the context of classical infrastructure, things which are in the pavement like loop detectors, cameras, and so on. And this picture is a good illustration of the revolution we just went through in the last 5 years. On the left, you can see what was the state of the art in 2007, 2008 in terms of traffic monitoring. And if any of you has used Google Traffic or Yahoo Traffic or Inrix or Microsoft Bing Traffic, whatever, you've seen pictures like the one on the right, which is one of the systems we've developed at Berkeley. It's called the Mobile Millennium system. And what's striking there is that there's information almost everywhere where there's a major arterial road, a secondary road. And that is basically due to the explosion of the smartphone and the cellular devices, which have impacted enormous amounts of aspects of urban mobility, and traffic was one of the first beneficiaries of this. So what we did at Berkeley is a good illustration of what can be done today in practically every field of mobility. At the time, we created a pilot system that we launched in Northern California that collected traffic from what was at the time the first Nokia app ever deployed in North America to gather traffic information from GPS-enabled phones. and broadcast this back to the internet. Of course, the university is not in the business of competing with the private sector, so today we operate this in the brokering agreement with companies. We get data from companies, but just to give you a sense, for Northern California, we get 60 million GPS points a day, and that's just one of the many sources of data we get. And that's a tiny, tiny amount of what's available today to characterize urban mobility, and I think this is just the beginning of an extremely radical change in paradigm in urban settings. If you want to power a system like this, you have to have a very specific set of sub-tools that are using to clean the data, to filter the data, to infer things where you don't have data, and to generate information. And I want to go through this, but the point I want to mention here is that anybody who is in the business today of gathering amounts of data, and we'll hear from Stamen, the things they've done, or even Paul building the urban sim model, requires enormous amounts of computation and architecture. In fact, Paul and I are part of the AMP lab, which focuses on definition of such architectures. And in terms of revolutionizing mobility and urban environments, I mean, I think the backend, what we don't see to process that data, is extremely important. I really have to express my thanks to Stamen, because we've been working a lot with Stamen in building this, but this shows you an example of maybe 0.5% of the data we get for California, and this is 500 taxis leaving a GPS dot every minute behind them, and it's kind of an inverse Pac-Man display here. And what's amazing there, and you'll probably see even more beautiful pictures in a bit, is the amount of data there is today to characterize traffic. This was not even thinkable a decade ago, and this is a minimal amount of what's available today. This gives you another couple a sense of what these pictures look like, and the resolution that you get. You can even see the international terminal at the airport because of GPS occlusion. So this has completely changed the way we do business. Now, there's a lot of issues there, all right, because people are being tracked with phones. They probably know it. They probably don't know it. Sometimes they accept by pressing yes, yes, yes when they install applications. So I understand this morning privacy was an important topic. There's one thing which is interesting when you think about citizen engagement is there are ways to gather data which not only are anonymous. Anonymity doesn't do much because it's very easy to reconstruct personal information, even from anonymized tracks. But there are ways to gather information which are less intrusive than others. And one thing that maybe we'll talk about in the panel is how that can be done. The idea is simple, is to create virtual portals by which when a phone crosses a portal, it will send some information, but it won't sell everything you're doing. So the way it works is you have these portals which are part of the app you're running in the phone, and when the phone crosses the portal, it sends some information, but it doesn't sell all your information. And so I think that's important because a lot of these systems are based on citizen engagement, and citizen engagement can only be achieved when there's trust and, in a sense, the idea that nothing will be done with the data. And this is very important because if you just think about transportation, all these pictures here show you a source of data that is routinely used today by someone to do transportation. This one on the top left is my favorite. It's aircraft circling around cities and basically getting 50,000 cars moving at the same time to understand where people of interest are going, and you can imagine where that's deployed. The other two ones are also ones I like. These are the pictures we get from the DLR. Basically, that's the German NASA, and they reprogrammed the satellite to orbit around California so we could study California traffic. So it's not just in the movies. You can monitor traffic and people's motion with satellites. And of course, all the classical stuff, the cameras, the loop detectors, the radars, the thing you carry in your car, the fast track, taxis, cell phones, etc. There's many, many more. So we're just at the infancy of what can be done with this data. I think things like Google Maps and Google Traffic are first instantiations of some of the revolutions that are yet to come, but it's just the beginning. Specific to the future, what we're interested to do with California is to link all of this. And what does that mean? That means that now that you have all this information, you can start to reroute people, and using tools like the one that Paul is developing, you could try to figure out the best way to allocate traffic in real time based on the predictions that the tool provides. And again, I mean, the data is just getting there, so I think we're going to see enormous changes in the future. It's not only coordinating the infrastructure, it's really about understanding where people are going and what to do about it. And of course, this goes beyond traffic. If once you have traffic, you have a lot of problems nailed down too. For example, if you have traffic, you can have real-time assessment of noise levels in cities. And in some work we've done with Edmund Seto, this is what can be done to produce maps like this. If you have traffic volumes and truck penetration and maybe some sensing, you can now assess pollution and how that impacts specific sets of the freeways. And if you have weather data, you can see which neighborhoods will be specifically impacted Also work done with Edmund Seto and with Ron Cohen, not here only in California, but also in Paris. And so you can see more and more is becoming available. And just want to give one last example before I completely run out of time. But if you think about citizen engagement, I mean, in a sense, every one of us here is a source of data for something. And so you could even push it to the extreme where you can think about humans as sensors for earthquakes. There are apps now that can be used, and we've deployed one of them with T-Mobile, where when your phone is charging at night or when your phone is resting on the table when you work, if an earthquake happens, it will sense it, send it, and then if you have a lot of this data, that provides much more accurate information that is currently available due to the limited sensing we have here, and that's a project we're doing with Richard Allen. And so just to leave you with one last movie, which is my last slide, I promise. This is an example of how you test these things. That the beauty of UC Berkeley is we have these big machines called shake tables, where we have recorded all the famous earthquakes in the last decades. And when you it's not like on Star Trek where they shake the camera to make it look like you're in space. This is actually shaking for real. This is how these things are tested. So you can see we started with monitoring traffic with the phone, and now we're all over the place with air quality, noise, earthquakes. Obviously, this paradigm of sensing, this paradigm of data fusion at large scale is going to change and has already impacted the way we design urban space. And I think one of the things I'm interested to discuss in the panel today is, the type of breakthroughs that can be achieved through visualization, simulation at large scale, and other topics. So I'm going to stop here and leave it to the next panelist. Thank you.
All right, I'm experimenting. So far, the experiment has gone well. I've just tried using my iPad for the first time for a presentation. I'm Paul Wadell, and I'm chair of the City and Regional Planning Department here at Berkeley. When Alex found this out, I think he gave me his condolences rather than his congratulations, which is an appropriate response. Anyway, I'm here to try to address the two themes of this panel, data democracy and citizen engagement, which I think are quite closely related. And I'm going to do it in the context of land information systems and a planning project that's underway here in the Bay Area that we're heavily involved in called Plan Bay Area for trying to address the challenges of reducing greenhouse gas emissions through the way we configure land use and transportation systems in this region. But I'm going to start with the data democratization aspect, and I'll talk about urban data from a land use perspective, as would be appropriate for somebody in city and regional planning. Most of you probably have dealt with parcel data. You live on a parcel. Your house or apartment is located on one. It's the unit of land ownership or of land regulation in the US. It's the unit of land that's bought and sold or developed or subdivided or consolidated by developers for producing real estate development. There are lots of attributes about land and parcels that are being tracked by public agencies, including transactions of properties, the sales transactions, how much properties are sold for, when they're subdivided and how so, or consolidated, the use of the land in that parcel, whether it's industrial or commercial or residential and so forth, what the zoning is, that is, what entitlements the land has, what kinds of buildings could be built according to local regulations. And then there's a stock of buildings themselves, what kinds of buildings, of what intensity, what styles and architectures and so forth are present on those, and what is their value. And information about ownership of the land as well, and the assessment of property taxes by various overlaying jurisdictions. So it turns out that this is really crucially important data infrastructure for all kinds of reasons, for infrastructure planning, for emergency preparedness planning, for looking at the impacts of hazards, whether natural or man-made. The land information system is really crucially important to that. So who maintains all this wealth of data? Well, the property tax assessors in every jurisdiction are responsible for maintaining the data for tax purposes. Often that's done at the county level in the United States. But cities and title companies and other entities play roles in collecting and maintaining parts of the data. So it's a fairly distributed but somewhat institutionalized set of players that are involved in this data infrastructure. And yet, we do not have a national data infrastructure for land information systems. We have a lot of fragments. A lot of jurisdictions have digitized their maps and organized their attribute data into electronic databases, but there is really very little in the way of standardization. The accuracy varies tremendously from place to place. The projections, the coordinate systems, the attributes, the formats the data is stored in, all vary tremendously. There are no national standards of any kind that apply uniformly across the country. And a lot of localities actually still lack the basic either cartography or attribute data. And often when they have it and you look at the data dictionary for these, it looks like it's going to be a wonderful database, but then the columns are not actually all filled in. There has been interest in creating a national data infrastructure for land information for quite a long time. Since the 1980 National Research Council report called The Need for a Multi-Purpose Cadastre, which 27 years later, was revisited by another NRC report called the National Land Parcel Data, A Vision for the Future. It still remained a vision. And there is another forthcoming report that will update these prior works. It's been a long time that we've been talking about building a national infrastructure for this data, and it has not happened. I was involved in an early effort to create a data clearinghouse in the North Texas area back in the early 1990s. But many of these efforts just have sputtered and not really proceeded. So the private sector has come in and stepped up for their own individual proprietary purposes, of course. If you look at Google Maps and zoom in, you'll see parcel boundaries, but you can't experiment or explore the attributes of those. Zillow and other real estate companies allow you to explore some attributes of the parcel data, but again, you cannot extract this and use it for your own research purposes. And then there are aggregators of data that have gone to the individual jurisdictions and collected data, like Boundary Solutions, and you can buy this data for up to $1 a parcel. Volume discounts are available. So for research purposes and as a public resource, I think these are somewhat unsatisfying outcomes. So I'm going to turn slightly now to the community engagement part of this, but I'll reach back into the discussion that I just started about this land infrastructure, information infrastructure. The project that we're doing in the Bay Area is called the Urban Vision Project. It's a software platform that we've been developing to support regional planning and community engagement in regards to the state legislation to reduce the impacts of urban regions on climate change. So what I'll do is describe, I didn't mean to go there yet. The data sources for this are built on and around public information for the most part. We start with digital terrain models of the region. Then we obtain digital orthophotography, which gives us very high resolution imagery of the landscape from the top down. We use another open data source called OpenStreetMap, which is a crowdsourced map of the globe at this point. It's a fabulous project, and it uses individuals as the data sources for improving the quality of the data over time, and it's completely shareable and reusable. We obtain parcel data and building attributes from the individual assessors in the region and have worked with those data in spite of many limitations. Building models from Google where available, and then a method that I'll show in just a moment for creating building models, 3D models on the fly. Zoning data from cities, general plans from the cities, plan developments, business establishments, census data, and various planning geographies are all fused in this data system. And a technology that we've developed, and I think this was going to play earlier, and it's not now. I'm going to actually skip to the YouTube video at this point to show you. It's playing on the TV. Okay, it is playing. Good. This is showing the work that we've done in the last year and a half to create a rapid visualization system for community engagement. And all the 3D models of buildings here, except for a very small number, are generated on the fly from attributes of the parcel data. So it's a way to rapidly generate 3D visualization of urban landscapes both showing existing conditions and being able to edit the attributes. Back to the crowdsourcing idea, the use of OpenStreetMap as a crowdsourced application we think could be extended to edit the attributes of parcels and buildings and other urban characteristics as well. So we've also got capacity to animate pedestrian and traffic flows using the same kinds of data that, that Alex was showing earlier, or simulated results from transportation models. The key to this particular project is that it's not just about visualizing what the city looks like today or the region, but it's about experimenting with different policies so that we can alter transportation plans, alter zoning and general plans, and then examine using analytical models, urban sim in this case, and transportation models. If we alter the land use regulations like zoning, building heights, restrictions on setbacks, what types of buildings can be developed, we can visualize it to show communities what those land use regulations would actually look like. And then we can model the real estate market to show what the impacts would be on property values and on the likely outcomes in terms of development. This is the interface we use for allowing users, which could be planners or it could eventually be community residents, to actually edit the zoning regulations and store a scenario that is a set of policies that we can then analyze using the models and then visualize using the 3D visualization platform. So the final part of this is to engage the community in the process of evaluating alternative outcomes, alternative policy packages and scenarios. So one part of what we've done in that process is allow fairly rapid prototyping of different scenarios so that the allocations of those scenarios can be visualized, and then a split screen view with a time slider at the top that allows us to visually compare two alternative scenarios over time and look at what the implications would be for densification and patterns of urban development. So we think that this kind of a platform has potential to change the dynamic of community engagement and let communities more actively get involved in the process of designing policies that meet their own needs, but that also address regional needs, such as climate change impacts that go beyond the community's boundaries. So with that as a way to open discussion a little later, I'll transition to the next speaker. Thank you.
Hi, everyone. Good, that works. Can everyone hear me okay? Okay. Let's see what the story is with my connection here. Much better. There we go. Pardon me, there should be a big giant piece of text on there. There we go. Hi everyone, my name is Michael Migurski. Thank you, Nicholas, for the introduction. I'm the technical director, CTO, R&D person at Stamen Design in San Francisco. We're a fairly small firm, about 13 people these days, that focuses on data visualization, map making, cartography, open source GIS, simulations, et cetera, et cetera, et cetera. And I wanted to take as a jumping off point for the talk today this idea of citizen engagement from the point of view of the actual citizen, and talk about a few of the projects that we've worked on over the years and kind of how they deal with citizen engagement from that kind of lower level individual point of view. I wanted to start by talking a little bit about how cities and urban sort of areas often engage their citizens currently along data guidelines. So as an example, I live in Oakland, here just south of Berkeley, and Oakland has a site called Crime Watch that it uses to publish crime data to its citizens. And if you visited Crime Watch during the past 10 years or 12 years or so that it's been active, one thing that you'll remember is that you are often faced with interfaces a lot like this one. Kind of vaguely user hostile, difficult to get around, basic like introductions to urban data that have you answer questionnaires. Where do you live? What kind of crime are you interested in? How many days back do you want to know about it? And only after you've run through this like brief gauntlet of answering questions and clicking buttons do you actually get to something that looks like a useful view of what your neighborhood is like with crime data. And of course, once you're there, you're faced with something a little bit like this. This happens to be my zip code in downtown Oakland. You can see that there's no crime icons outside of the zip code because you've specified a particular zip code and that's all you get. So you're basically kind of nailed down to this area and forced to decipher symbols a lot like these. The one on the left is a car for car theft. The one on the far right is a little spray can for vandalism. And then towards the middle, they get a little bit sort of strange and abstract. You've got that kind of black thing that's actually a knife for a robbery. All forms of narcotics are represented by a syringe. And the big pink P, I think, is where the designers chickened out and decided to represent prostitution in a more abstract sort of way. So we created a project called Oakland Crimespotting a few years ago, sort of spurred by an assassination, actually, of a journalist that happened just in my neighborhood around the corner from me. It's called Oakland Crimespotting, and a lot of the focus that we've put on crime in this is to basically flip that entire equation around and think about, using the same source of data, the same kind of per incident level reporting from the city of Oakland, but look at it from the point of view of an actual citizen. So for example, a citizen coming into this thing maybe doesn't want to run the gauntlet of all these questions, but they want to be faced with a map right away. So that's what we've done. You basically open up the site and the first thing that you see is the whole downtown chunk of Oakland with all the icons around. Same goes with crime categories. You don't want to have to run through this gauntlet of questions about what you're looking at. So for example, all the crimes are shown and you can use that area up on the upper right there in order to select individuals or collections of them. You can also roll over them and get the kind of Mac OS X spotlight effect, which is what you see in that kind of dark light area there. And then finally, we look at time as both a cyclical 24-hour clock and a calendar view. So the circle on the lower left-hand side is called the pie of time, affectionately by us, and it effectively allows you to kind of pick out certain areas of the day. So for example, you can just look at commute time and look at like 9 a.m. and 6 p.m. together. If you're somebody who lives in Oakland but works in San Francisco, you can look at evenings and mornings and during the night to look at what crime affects you. And you could use the bottom slider in order to see kind of, weeks, days, months at a time. So all of this stuff is really geared towards, taking these views of data visualization, common practices, things that as users of the web we're accustomed to on a daily basis, and applying it to something that is otherwise fairly user hostile in order to make it possible for people to understand the data. And a lot of the feedback we've gotten from this basically underscores that we think we've made a right decision. One particular guy named Simon, who lives in District 1, has told us that the tenor of his meetings with the police officers has totally changed since crime spotting became available to him. Where previously they would come to these meetings and the police officers would bring them data for the very first time. They would have to use the meeting to process information and then figure out how to respond to it. Instead, what they can now do is show up at these meetings with the data ahead of time. So everyone is sort of able to do their homework and able to come to these things informed and get right to that business of talking to their local beat officer about what to do about the crime rather than merely learning about its presence. Paul mentioned also OpenStreetMap as a project. This is kind of another example of where we're seeing a lot of very deep citizen engagement with the idea of urban data. For those of you who aren't familiar with OpenStreetMap, it's essentially like Wikipedia. It's a crowdsourced source of data. It enables people from all over the world to use things like GPS units, pieces of paper, mapping, kind of their own memories to create this hyper-dense, very, very detailed street map of the entire world. And what's interesting to me about OpenStreetMap is, one, it's a great source of data, as Paul mentioned, but also the origins of it. It started in 2004, 2005 or so, when a few of our London friends started basically bribing courier companies to give them GPS tracks and let them kind of put GPS units with these couriers moving around London. So OpenStreetMap started as a kind of cab spotting-like, sort of urban informatics-like view similar to this. And I think the real experiment there wasn't just can we track all this stuff, can we pull all this data, but it was also can we make something useful out of it? Can we turn all of these randomized little points and all these little dots and samples into something that actually has, you know, one-way markers, street names, street categorizations, building pathways, et cetera. And then moving on from there, can you actually extend this experiment out into the entire world? So what's happened in the meantime is OpenStreetMap has become in many ways the very best collection of street data in the world for almost any kind of use. One thing that we saw it used for was on Flickr.com, the photo sharing website. They have a map feature, and they realized around the time of the Iran protests in 2008 that Yahoo Maps, which was built into Flickr, didn't actually have any coverage of Tehran. So Tehran was basically, you know, two streets kind of intersecting, a little dot that said this is where Tehran is, and that's about it. Good luck, everyone. So what Flickr did was they took this OpenStreetMap data set and folded it into their maps in place of Tehran so that all the photography that was coming out of these street protests could actually be localized and positioned in some sort of useful way for Westerners and people outside of Iran to be able to understand. For our own purposes, you know, in addition to doing kind of the more cartographic visualization work, we also work with a lot of ad firms. So we worked with Weeden Kennedy and Nike as their client a few years ago to create something called the Nike Grid Run. Again, this is all based on OpenStreetMap data, based on the City of London where OpenStreetMap began, but it kind of puts a new twist on the idea of this urban informatics as a sort of venue of entertainment and a way of getting people out of their houses. The Grid Run was a 2-week project that Weeden Kennedy ran for Nike in London, and the essential proposition was to get people out and running. To get people to move around on their presumably Nike shoes and record what their runs looked like. So essentially what Weeden Kennedy did was they realized that there was this huge urban infrastructure in London of these disused phone booths. You know, today everybody's got cell phones, nobody really uses these things. They're essentially static advertising platforms as far as anyone can tell. But what they do have is a phone line running into them. So basically people would sign up to do the grid run and they would be given these lists of phone booths to run between and a runner code. So your runner code might be, you know, 6678 or whatever, and you would run from one assigned phone booth to the next and dial your number into it. And they would use that as a way to derive geographic information and timing information from you. So every single day they could create these super dense visualizations of all the different runners moving around town, what their paths and times were, how they were doing relative to one another. The advertising campaign around this focused on sort of an east side, west side competition, or a boys versus girls, or youngs versus olds, or kind of what have you. And it was just amazing to see this thing because, you know, you can imagine this stuff as kind of GPS units and technology and mobile phones and everything, but ultimately what they did was they saw that the citizens of London and the existing infrastructure were kind of a useful proxy for all the sorts of more, you know, dense, high-tech future technologies that you might be able to use for this stuff. And they went and just stuck with the phone booths. So I think the kind of question that I want to leave us with, unfortunately we only have about 20 minutes for actual talking time, which is kind of a bummer, but is really just this. Why are open source projects and ad firms doing citizen engagement as well as they are? What is it about people that have this kind of sideways relationship or not necessarily involved relationship to urban spaces that enables them to connect to this stuff and connect to it on a very sort of personal, citizen by citizen, human by human kind of way? Thanks very much.
I won't try and synthesize all the presentations into one sentence, but maybe actually I will. If only to say that I think if I go back to my opening reflections on what's different this time around with urban science, I think one of the things that we might argue is that we're moving very productively from the era of the model of the single algorithm that describes a complex system mostly inaccurately to the mashup, which is to say new and unexpected different kinds of connections between real, social, environmental networks in the cities and the technology that allows us to hopefully understand them and maybe even shape them. But I'm going to stop talking now, but I'm going to ask our panelists, first of all, if they have any questions for each other. In terms of the connections between the different scales of work we've seen and the different kinds of work we've seen, maybe on this theme of hierarchy and understanding and maybe even the mashup as well. And if that fails spectacularly, then I'll go to the audience in an event to get the conversation started. But Take it away.
I have one question for Paul. Is how does your work complement with the private sector? Because in a sense, it seems there's enormous complementarity. That the issues you mentioned with Google is their attributes cannot be queried. You provide an open platform for research. So in our case, we always have a very simple pathways. We would develop technology, and then the companies would take it over because that was productifiable. How does that duality play in your case?
It's still being worked out. So I think the completely private sector solution so far has not resulted in either complete coverage of a national data infrastructure, nor an accessible enough data infrastructure where it is available. So I'm actively exploring taking a much more open, community-based approach to this, which I think in the same way that OpenStreetMap has become used in a lot of commercial products, I think such an open infrastructure could be used in both open community-based products and in commercialized products. The data itself would have to remain open in this if it follows the same kind of approach. But I think we're seeing that the open source movement has moved from software to data, open content, and I think this is an increasingly vibrant and active space, and has room for both private and public directed projects.
You know, I don't know if this is working. Just to jump in there, I would actually just underscore the importance of that collaboration between private and public and community, actually. So we work in this space where there's a standard called Open 311, which is open data standards around issue reports in your city. And there's a data standard there called Open 311 that's actually kind of stalled. And the development of it hasn't been as proactive as you would hope because there hasn't been a strong private entity wanting to make it happen. And then you contrast that with, say, the development of GTFS, right, real-time and just general public transit data. Now that's actually taken off. And I think when you have governments and public institutions understanding the value of open data and then a private driver really making it happen, you can get a broader scale than you can if it's just a nonprofit or a community-led initiative.
I think that the dynamics of that, here we go, the dynamics of that GTFS process, I think, are really instructive for a lot of this other kind of questions about parcels, for example. You know, in particular, what Google did there was they created a transit feed specification that would feed a visualization that they provided. So there was basically no question in the minds of the different transit operators whether it would be useful to publish their data. They immediately knew that it had a place to go. So I think that kind of design visualizations, you know, all these kind of private sector attempts to show data have that kind of pulling or drawing out effect. So Paul, for example, I would be really interested to hear from you, you know, who are you talking to about the parcel database? Are you getting any kind of traction from tax assessors in order to actually open this stuff? And do they need something like a, you know, open parcel spec in order to make it useful for them?
There are many thousands of these tax assessors, and so no, we haven't had a large scale. Yes, right. It would be a lively discussion, I'm sure. But I've explored even what some private companies have done. There's one here in California that has apparently developed individual relationships with each assessor's office in which they have obtained direct access to the computer system of the agency. And in exchange, they use the data and return some share of the revenues from reselling the data to the agency. That's an incentive structure that seems to work. Whether it scales up or not is another question. So, you know, what's different in the parcel data case than in the OpenStreetMap case is it's in some ways much more dispersed in the OpenStreetMap case who the maintainers of the data would be. In the case of the parcels, you have a more institutionalized and concentrated maintenance structure, and the data has to be at some level more validated for public use. So there are some unanswered questions about whether this is feasible. Maybe this is why it's taken federal initiatives 30 plus years to not get the job done. But I do agree wholeheartedly with the idea that some combination of public and private approaches to this would probably be the most beneficial to move the dial forward.
You know, it's interesting because I think GTFS is like the paradise situation, like you mentioned. You know, Google creating the standard and every possible public agency playing with, and that's great. I think this you're describing is the next level of paradise. It's not as nice because now you have the fragmentation. I live in hell in the sense that if you talk about live data for traffic, not only you have the fragmentation. Now there's not 1,000 companies like you have 1,000 assessors, but the main difficulty is that the people who own the data are from the private sector, and their business model rely on the use of the data. Therefore, they will absolutely not share the data. So it's a very different situation, and so traffic is obviously one of them, but there's many other fields like this. And so I think there is an interesting distinction in citizen engagement and the use of the data is for those fields where we have the luxury to rely on public data, for example, water, maybe the parcel, then in a sense, the difficulty is purely institutional. And it's very difficult because institutional barriers can take years, if not decades, to be overcome. Now, when the data also relies on private sector business interests, now there's another whole dimension which is even harder to overcome, which is now you have to create a market for it. In the case of traffic, we're working with the California Department of Transportation on trying to get people to sell to California their data because California needs that data. And so you can imagine now all the issues of privacy and commercial interest. And so I don't know, does that even show in, do you have sources of data like this that are interesting to what you do, that are actually owned by the private sector? And how do you deal with that?
Again, there are a whole set of complicated issues that arise when you look at different aspects of the data. There are commercial real estate companies that collect information such as CoStar and DataQuick on rents, on vacancy, on the attributes of non-residential buildings and so forth. And those are proprietary data sources. So you can purchase them and you can analyze the data, but you can't redistribute the data. And it's also relatively unlikely, I think, that that data could be, well, I wouldn't rule out the idea that you could crowdsource that sort of data, but complete coverage would be a challenge. And simply turning on a signal coming from the cell phones and getting a large enough body of users providing that isn't really an option in this case. There's not, it would take a much more active level of cooperation with the agencies that have access to this data.
I'd like to jump in and ask a kind of meta question to Abhi and Mike in particular about the issue of interface and design. And I'd really probably be interested in everyone's thoughts on this, but the conversation that we've been getting into for the last 5 or 10 minutes is about this attempt to find a kind of absolute truth in data and the attempt to share data and create a kind of a Rosetta Stone of information that everyone can turn to. But by the same token, I think really interestingly in some of the examples that Jennifer showed this morning, showing Code for America's work, and also in Mike's example, the having good data seems to be one part of the puzzle. And as we try and build whatever discipline this is going to be, I think one of really important conversation is the role of design. Design is when we're dealing with traditional infrastructure in cities. In this country, design is seen as a kind of value added. This is why all your interstate highways look exactly the same, no matter where they are, because they're not designed except by the engineers that determine their trajectory. But I think when we're dealing with information, the issue of design is non-trivial in terms of the difference, for example, between the pixelated prostitute P and the Oakland crime spotting. It's an interface that's different enough that it becomes a thoroughly different thing in terms of its social and urban life. So maybe you could talk to that issue, and in particular how you would encourage the group who is trying to build this field to integrate design thinking as a part of the kind of common curriculum, as it were.
Yeah, I mean, I think that as far as design thinking goes, probably one of the most influential words that I've heard spoken about that recently was Steve Jobs' idea that design is how something works, that it's not the superficial kind of curly cues on the outside or the choice of this kind of rounded corner or that kind of rounded corner, but it's the overall sort of experience that you have as a user or visitor to it. I would be really interested just thinking about this kind of opening of public data, basically how you use the experience design as a way to help draw that out. Like I'm thinking about historical examples, and I think about how every transit system in the Bay Area used to basically be like sort of a private bus line, private ferry line, key route, all that kind of stuff. And it was all basically unified into things like Muni and AC Transit and so forth, 60, 70, 80 years ago. Not sure exactly when. And we're starting to see another unification right now that I have very high hopes for, which is the Clipper card. I don't know how many of you have seen the Clipper card, but it's sort of like the Oyster in London, where you just have this, this wallet wave hand throw gesture that gets you onto like any bus in the entire system. And I think about that as a kind of experience design or design question, because suddenly this gets me onto a bus instead of farting around looking for change, looking for dollar bills. And I'm really interested in the ways in which the expectations of that kind of very simple design gesture start to kind of, unify transit agencies or change expectations about the openness of certain kinds of data versus others.
I was just going to add kind of a practical note while thinking about that. I look at design as kind of giving life to data. So it's taking something that's just tables on a spreadsheet or numbers and making it actually tell a story. And when we think about data, and I think this is what Jen talked about today, I wasn't here for that, but you think about impact, right? And what's the role that this is actually going to have for a citizen? And I think it comes down to ROI, right? Like, what's the return on investment for a government, an institution, for opening up this data because they don't have to do it, right? I mean, there are mandates that people are supposed to be open. There's dictates from the executive offices. You still don't really have to get that spreadsheet that you have in your My Documents folder onto the open data portal for everyone else to get. You don't have to do that, right? So you need to show ROI. So there's a story we had in Boston last year, and you guys mentioned privacy. We were working with the city of Boston, and they have a problem in the winters where it snows a lot, and so the school buses for children get delayed, right? So then the city gets thousands of phone calls, and it's like a staff of 5 people in the school department, school district saying, oh, your bus is at this street and Tommy will be home in 50 minutes. And they have GPS on the buses though, right? So they have the data. And we were like, wait, you have real-time data about the buses, and instead of making an app, you're answering the phone over and over and over again. And they're like, yeah, but it's too much of a privacy restriction, because they couldn't see the app that we could build that would actually solve that problem, right? So we just built it, right? We didn't have the data, but we just built a mock-up of what it would look like. And the next day we go back and show it to them, and they're like, wow, you could actually do that. And I guess this is what I'm getting back in terms of design giving life to data, that if you can actually just mock something up, show it, make it real, you have a much stronger ROI and a much higher probability of actually getting the data you want. And when you're getting it, and this is one of the most effective and sustainable applications Code for America has built in the last 2 years.
I really like the concept that you had of almost, I would call it like designing mobility in urban space. It's almost design meeting engineering. You can even push it further. I mean, I think the Clipper is a fantastic example of an integration, micro-integration. The Fast Track is also another example, because you can pay the toll, you can pay the parking lot at the airport, and so on. And I think there's great hope that maybe companies like Google, companies like IBM have enough foothold on the infrastructure to make this happen. If you think about a travel, when you're taking a plane and then a taxi or renting a car and then parking, all of this could be part of one service app that runs on the phone. And I think Google has already started integrating their services. But I think at the end, it really boils down to designing a service. And it's really a mobility service. And this is where I think, of course, it's going to generate a lot of data, like you were saying, but it's also enabled by all this data and these services. But I think there's only very few entities that can create that. I mean, I think Google is one of them. IBM is probably another of them. And there's probably another handful who have enough foothold on the infrastructure to make this happen. And that's really a dream, but I think that's happening.
So if I can throw my 2 cents on this one as well, there are a couple of different dimensions that I might respond to this one in. One is that I think what we can begin to do is explore and reveal urban design through the ways we visualize this kind of data, both the street configuration and the layout of urban development in ways that are really valuable and important to people. We're finding that people are interested in metrics like walk score that start to quantify in some way their level of accessibility to amenities within walking distance to wherever they're exploring. So I think being able to both measure and represent urban design is an important part of this particular conversation. Flipping to the other side, representation and design of the representation is another aspect of the user experience, as has already been mentioned. When we started showing 3-dimensional visualizations of the alternative scenarios to community groups and so forth, we got an interesting mix of responses. On the one hand, people in some cases were somewhat mortified that these were not exactly the right looking buildings that they could recognize in their neighborhood. On the other hand, they wanted to be able to see something fairly close to photorealistic in terms of what their neighborhood might look like if you adopted different policies and had different development patterns. And so we haven't fully resolved this, but I think having a lot of sensitivity to how the design is interpreted and how the representation is interpreted by whoever the users are, the community, the planners, residents, businesses, and so forth, is an area that we need to pay a lot of attention to. So I fully agree that it's not just about the information content and access to it, but also how we make it available, how we represent it, and how we represent design in that whole process.
I think we're just at our time. I think I'll leave you with the anecdote that in any architect's life comes the dispiriting notion that they haven't built it exactly as you intended it. They've built it exactly as you drew it, which is always quite a slightly different thing. And I think that especially as we make tools and interfaces, we need to, I think especially keep including a conversation about the shape of those tools and interfaces, and because they are how we touch the data and how we see the data, and they are what gives life to the data as it continues to shape the urban conversation. So thanks very much for joining us for this panel. I'm sorry we didn't have time for questions from the audience, but these people aren't, with the exception of Alex, these people aren't going anywhere in the next 5 minutes, and you will have the chance to chat with them and continue the conversation more informally. We could take Tim a group, fantastic. So we've just been allotted an extra 10 minutes. I'm going to give Alex the opportunity to step out because I know you said you needed to live right at...
Sorry I have to leave early. But
Yeah.
Thank you.
Let's give Alex a hand as he goes. And thanks for joining us. And we'll take questions for myself and the remaining panelists for the next 10 minutes if we have them. Yeah.
Thank you. Greg DeLon with Forefront. So I come from physical design and then urban and regional planning with economic development focus. And I think it's really interesting, first of all, this idea that you're talking about. We have the data that we're producing and new ways of producing the data, and then how do we get out there and use it? So Code America is doing some really amazing things, and then there's the question of how to use all this data. So as Professor Wadell was talking about, well, maybe we haven't fully addressed what's all the different ways that we can get those things to market and develop the products. With Stamen Design, I don't know how they came about, but the area that I'm working in now is that innovation culture, entrepreneur space, and some of the things that are going on, some of the tools for creating those new products and identifying these things are things like hackathons and venture programs that universities can get involved in, as well as private companies. So in a sense, what ends up happening is, rather than Code's model where they're going to a community and looking at specific data and trying to dig deep on a solution, you're creating an atmosphere where in the course of 12 hours or 24 hours, you get all these different people in the room and you generate potentially money-making, return on investment ideas for how to process this data. So you have your academics involved, you have your hungry startup guys involved that talk very different languages and potentially can really create some dynamic things. So maybe Michael can make a comment on that, but it would also be a bit of a challenge to maybe that's the sort of things that could be applied to make this connection and to support economic development and private sector participation to bridge that gap between the data and the application.
Yeah, absolutely. I mean, I think it's a great question. Thank you. I think whenever I think about hackathons, which are just such an impressive model for kind of creating a boiler room atmosphere for generating new work on top of existing public infrastructure, I always think about projects like, the Works Progress Administration from the 30s. I mean, all the parks in the U.S. are just dotted with these like stone heap buildings that have weathered the tests of time. And what the WPA did was they basically took their eye off the ball in terms of ROI for a little while and just said, well, we got to get these people to work, so let's just have them move rocks around. And stack them on top of each other until we have parks infrastructure and, you know, roads and all this other kind of stuff. And we're still reaping the benefits of this kind of government as backstop model from, you know, 70, 80 years ago, even today. You can go to Temescal Park and there's that boathouse up there, which is, you know, 80 years old and still going strong, still looks great. I think that government data has a similar function in something like a hackathon. The idea that you can get together with a bunch of people in a room and do something like a crime visualization or, you know, stuff to do with the school buses in the snow is unbelievable, especially when you think about how you don't have to include in that hackathon the problem of, you know, knocking on somebody's door at City Hall and bugging them for that data, because so much of it is available in open source. I think that's what makes the hackathon possible.
I would just add to that. Coach Merrick, we throw a bunch of hackathons, and they're a great way we engage people in the communities that we're in. And it's like candy. It's like gets people so excited, and it gets people out there. And the challenge, though, is how you sustain that energy and how you sustain those projects over time beyond the 24 hours. So we look at hackathons as part of a broader ecosystem of the kind of support you need to make really sustainable civic innovation. So we actually have a startup accelerator, which is focused like Y Combinator, if you're familiar with that, focused specifically on for-profit ventures in the civic space. So taking government data and making for-profit industries. And this year, our first year, we had 235 companies apply for 7 spots. So there's actually a really growing market there, which is pretty exciting.
I'll throw my 2 cents on this one as well. We've also seen a tremendous amount of innovative technology development and sort of nascent ideas, things that look like they have potential but need private nurturing to really go to scale. So we've actually started a process that has now arrived at a startup spin-off from Berkeley, and we'll be formally launching it, website set up and all that very soon. But it is to try to bring some of these kinds of technologies up to scale and enter joint ventures with other firms to really make it happen.
Stefan Lehman from Sydney, from Australia. I would like to bring the discussion back to city design and the question about public space. And as Carlo Ratti from MIT claims, we're going to see new emerging types of public space coming out of all that. Can you point to any of those new types of public spaces that you see? You mentioned, for instance, London and the new role the phone booths are playing. Are there really new types of public spaces emerging as a consequence of the data flow? And if yes, which ones? Thanks.
That's a really hard question.
Yeah, I don't Mike?
It's interesting because, you know, when I think about public space right now, like it definitely seems like the opposite motion is happening in a lot of places. You end up with these kind of semi-public private spaces, you know, the idea that you can walk along a sidewalk and kind of cross one of those invisible, like, plaque-marked barriers that says, like, permission to pass beyond this point is only subject to the blah, 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 the management. So it's interesting to me that a lot of the best public spaces that I see these days are more virtual than physical. Sort of, you know, Metafilter for online discussion, OpenStreetMap for, you know, playing with data, Wikipedia for kind of co-creation of facts and history and so forth. So I'd be really interested to see kind of what the reality of future public space looks like, because right now it looks like it's kind of moving into these like airy kind of server spaces rather than physical ones.
I think that one of the fundamental problems which hasn't changed since the first generation of urban science to the present one is that there is, even though our technology is increasingly networked, and even though our city is fundamentally a network of networks as well, which is why we often find these interesting sympathies and mashups, it is the case that technology tends to have an innate tendency towards attempts to optimize. Optimize space, optimize time. This is what technology is really, really good at. If you want to put a 787 together quickly, using parts from all over the world, there's no way you'd be able to do it without a network of networks contributing to it. And yet, public space, I think Stefan's really correct to bring up the idea. Public space is the space in the city that very precisely cannot be optimized, in which if you think about the ways in which when that last chapter of Jane Jacobs, it was specifically an invective against the kind of urban science of its time and its tendency to oversimplify urban problems and to produce, for example, urban proposals that looked like zoning diagrams. If you could describe this, analyze the city as containing 40% retail, 40% residential, 10% circulation, you produced a series of rectangles that were, correctly scaled, but had none of the dynamics, the complex dynamics of the urban space they attempted to replace. And so, one of the ways I think in which we, as people, hopefully, who understand both technology and cities, need to stand guard on is the fact that public space is something fundamentally in which suboptimal things take place, in which people laze around, gaze at each other, do all the kinds of things that tend to lead to good functioning cities, but don't tend to be readily describable by a single number or a single position or a single location in space. And so the best public spaces, even of the internet, have tended to develop as secondary effects from things that were attempts to optimize other purposes. And so we can, if nothing else, attend to those opportunities as and when they arise.
One thing I'll add, just the change that we've seen, and this might be trivial, but like the one change I've seen in public spaces is that we're seeing more reminders that they're public. If you look at the work that Candy Chang is doing in New Orleans, and actually some of the teams of ours in like Philadelphia and Detroit, they're trying to remind people that a public space is theirs, and its identity, its look, its field is up to them, and then giving them the tools, leveraging network technologies to actually provide an input, to provide some response to how it should look like. So in a notion of like an evolving sense of citizenship in a city, I actually think that's kind of interesting. It's not as transformative as you think we might want to hope with the technology that we have, but it's getting there, and I think it's signaling the right thing.
There's one other example that I might just raise. It's perhaps a bit different than these, and that is that I've seen some examples, not very many yet, but of real estate developers that have begun approaching the development process in a very different way, in which they're attempting to engage the community in articulating what their interests are, what kinds of projects they would like to see, what kinds of amenities, what kinds of businesses. And some have very interactive websites to support this kind of engagement. And they're trying to essentially generate a more community-based set of ideas about how to proceed. Of course, this doesn't generate necessarily good designs, but it generates something that gives a sense of what the community would support, and then they can analyze whether it's feasible or not. Whether that will generate really interesting, vibrant, messy places, that might be a more likely outcome than an elegantly designed public space. So I think you're raising a really important and difficult question about the role of community engagement and information technology in what is obviously a very messy space.
You want to take just one more question, and then I think we do need to move on.
Hi, my name is Allison Lassiter. I am so inspired by a lot of the stuff you guys are doing with user-contributed data, but I have a hesitation when I've been working with it myself or thinking about working with it, which is related to the reliability of the data. So error and uncertainty are a huge problem with geographic data in general, and when it comes from a government source, it's been maybe controlled in some way, or at least there's a person to talk to about it. But when it comes from a huge variety of people, how do you know that your data is good? And furthermore, do you ever fear that somebody would try to game the data in some way or another to manipulate the analyses that you're doing?
Yeah.
Feel free to start. No.
Sure. Yeah. No. That's absolutely the core question of open source data projects and crowdsourced data projects. I think things certainly get gamed. The sort of standard issue response that you get from a project like OpenStreetMap or Wikipedia is the idea that in open projects, many eyes make for shallow bugs. So getting a lot of people looking at something makes for problems that get fixed really rapidly. In the case of Wikipedia, what happens is that typically an editor will be around to sort of clean something up really soon after you mess it up. In the case of OpenStreetMap, it's that somebody will notice the dirty pictures you're drawing up in Greenland and kind of clean them up after a while. But it's definitely a problem. I would say that I think we've seen the same kind of problems in government-provided data as well. Not quite the dirty pictures version, but the sort of mislabeled streets or misspellings or old freeways that are gone, paper streets in the case of San Francisco, a lot of these kind of concepts. And generally speaking, what we found is that even though a commercial data source gives you somebody to sue, and a government data source gives you somebody to complain to, an open source data source gives you the possibility of being able to fix it right away. So in all cases, you're dealing with sort of sources of uncertainty, and it really is a matter of what type of uncertainty you're willing to stomach. In our case, we found that for cartographic purposes, OpenStreetMap is totally A-OK. We've never really found it to be a problem, except maybe sort of incompleteness in places where it hasn't been attended to. But we've also had similar problems with commercial data. So it's really kind of a balancing act. Like I wouldn't say that commercial data is necessarily strictly valid and open data is not. It's more like, what are they optimized for in different cases?
So I would echo your concerns, Allison. Doing any kind of analytical work, research on urban data where your interest is in quantitative results that need to be robust, and you need to understand what the level of uncertainty is. This is a huge challenge. And I'd say it applies whether or not it's a crowdsourced kind of a data application or simply analyzing government-provided data. There's a huge and growing field of big data, data mining, machine learning techniques that attempt to quantify and measure the uncertainty in data, attempt to model data relationships, and use those to inform the degree to which we can have confidence in the data. And I think the combination of big data techniques and crowdsourcing is a really intriguing combination, so that when we get an input from a user that's correcting or modifying data, we also have potentially another process that's running that's analyzing how probable is it that that change is an improvement in the data. In addition to the data editor that's coming along and cleaning the streets afterwards. So I think there's a tremendous active research area here, but your question is spot on. It's really critical for being able to make use of such data in a scientific endeavor.
Great. We should probably move on to the next panel. So thanks very much, and look forward to continuing the conversation.